Hi, and welcome to this video demonstration of EasyNAC. EasyNAC is unique because it's an agentless solution and doesn't require network changes. Before we begin the demonstration, let me quickly cover the key features and the solution's architecture so you have a better understanding of how it works. EasyNAC provides immediate visibility of any new device joining your network and will automatically profile them. Then, using policies, access can be granted based upon the situation. For example, if the device is unknown or untrusted, it could be assigned restricted access. If the device is AD joined and compliant with policies, it can be granted full access. If AV is out of date, maybe partial access or limited access. If they're registered for guest access, they can be granted internet only. EasyNAC also works with many different third-party solutions for AV compliance checks, patch compliance checks, or for automated threat response. I'll go into more details during the demonstration. And then also EasyNAC provides a captive portal for BYOD and guest registration. EasyNAC uses ARP enforcement to quarantine rogue and unknown devices on the network. One of the key benefits of ARP enforcement, it doesn't require any changes to your network, so you can deploy it very quickly. Let's say, for example, we want to quarantine this laptop. It joins the network. For this laptop to be able to communicate on the network, it needs to issue ARP requests to learn about the MAC address of the IPs it's trying to talk to. So for example, if it wants to talk to the default gateway, it needs to issue an ARP request who has this IP. Everyone on the subnet will see that ARP request, including our appliance. And our appliance will reply to it to tell the laptop, oh, you want to talk to the default gateway? Send that traffic to my MAC address. And the laptop will do that. It will send the traffic to us and we'll just drop it. Now that's a little oversimplified because we'll also tell the default gateway not to reply to the laptop directly, but to reply to us. So the appliance can put itself in the middle of the communications between the rogue laptop and the default gateway, blocking any traffic that we don't want to go through. The same thing for if it tries to communicate with a trusted endpoint. We're basically put ourselves in the middle of the communications, dropping that traffic. For devices that are trusted, they get left alone and they get normal ARP information. Now let's take a quick look at the typical architecture of an EasyNAC deployment. For ARP enforcement to scale, we need to have layer 2 visibility across multiple VLANs at the same time. One of the easiest ways to achieve this is to use a trunk port. When using a trunk port, we basically have visibility and enforcement control over multiple VLANs at the same time. In fact, a single trunk port can support 100 VLANs at a go. If you're a distributed environment, you can consider adding an Access Mini appliance at your branch locations and then centrally managing those appliances with the Central Visibility Manager. There's a number of different options we have for branch offices, so check with us what might be the most cost-effective for your deployment. Now that I've shared a brief introduction, let's jump into the demonstration. We will start the demonstration inside the overview screen. This is the web interface to the appliance, and it's showing us the current status of the network. We can see there's currently 4 devices on the network. One is a Linux device, that's my default gateway. Then there's 3 Windows devices. Of these devices, 2 are currently being restricted and 2 have full access. Let's go ahead and drill down into the Windows devices so we can see what they are. We're currently using this server that's on 100. I'm using the web browser of this server to look into the appliance, to manage the appliance. This device is my AD server, AV server. It's currently on the whitelist, so it has full access. The 2 devices being quarantined, one's an XP and one is Windows 7. All this information we see here is what we see from the automatic profiling, the host name, the operating system, etc. Let's take a closer look at the XP machine. So I'll go over to that VM, and this guy's currently being quarantined. So what that means is he can't access the AD server. We're going to try to ping 100. It's not going through. He can't access the default gateway. The same thing here. He's effectively quarantined. Now let's take a look at the ARP table so you can have a better understanding of how the ARP enforcement works. I'll go ahead and look at the ARP table. And what we basically see here is no matter what device he's trying to communicate to, it's going to get redirected to the appliance. The appliance is on IP 220, and this is the proper MAC address of the appliance. If it tries to talk to 100 or 254, as he's doing here, it's going to be also directed to the appliance. Now, if I want this guy on the network ASAP, I can go back to the management console, and I can basically, instead of using policies to assign access, I could basically hit the on button. This is the equivalent of putting him on the whitelist. So when I do that, his device would be immediately whitelisted, and here see his pings are starting to go through basically immediately. He's now on the network. If we look at his ARP table again, I'll just have a quick refresh of it. And here we can see now that he can talk to the MAC address of 100 directly. This is the real MAC address of 100, and this is the real MAC address of the default gateway. So he's no longer being ARP enforced. He now has regular direct access to the network. Now, some of you may be wondering, is it possible to bypass this solution by using static ARP entries? Let me quickly show you that it's not possible. Let me go ahead and copy this correct MAC address for the AD server, and then I'll add a static ARP entry for it. We'll look at the ARP table again just to make sure it's been set. And yes, we now have a static ARP entry. We know this value is correct because the pings to 100 is still going through. Let me go ahead and quarantine this endpoint again. I will do it by putting him in an off state, or I'll just let it back in policy mode. It shows he's being restricted again. And if we basically look at his device again, we can see that the restriction is still working. He still cannot talk to 100, even though that static ARP entry is there. Now you may be wondering, why is this working? Well, our enforcement can be two ways. So even though he can maybe send the ping out to 100, 100 is not replying directly to this endpoint, but replying to our appliance, and our appliance is dropping the return traffic. Let's go back to the management screen. So I just showed you how we can assign access to a device by hitting the on button, and then quarantine it again by hitting the off button or put it back in policy mode. You can use these on-off buttons for quick access for devices. But for most of your devices, you're going to want to use policies to decide what access you can get. And when it's in auto mode, that means we're automatically assigning access based on policy. So let's take a look at some of these policies that you can set. I'll go ahead and open up the device and role classifications. And this is basically a top-down list where if we look for certain conditions and those conditions match, you can assign the access associated with those conditions. So this is top-down. The first one that matches is the access you get. So for example, when I put the XP on the whitelist, he was assigned full access. If I had put him on the blacklist, he'd been restricted again. If the device had an event like an infection or APT event, etc., it would be assigned a high-risk role. If it had AV out of date or AV off, it would be a non-compliance role. If he was a trusted device, AD managed and AV managed, he'd be assigned full access, etc. And then these rules down here for BYOD, we'll cover them later today. But if none of these conditions apply, you get assigned the untrusted role. So that's how the device classification works. You can add new rules, you can move these around and adjust them just the way you need to. Let's go ahead and go back to that Windows device or the Windows devices. And let's turn our attention to the Windows 7 machine. So the Windows 7 machine is currently restricted. If I want to know why he's getting the untrusted role, I can click on that and it shows me my policies. And where it's red, it means he failed that condition. So when you fail all conditions, he's getting the untrusted role. But this Windows 7 machine is actually AD join. So let me take a quick look at the Windows 7 machine. And I'll start those pings again to the router and to the AD server. And we can see both of them are not going through. And the reason he's not trusted is I haven't turned on the AD integration. So let me go ahead and turn on that AD integration. What we're going to do is I'll go to my integration tab. And I'll turn on the AD integration. Now how this works, as I previously specified the AD server with the username and password, what we're going to do is we're going to log into the AD server, and if the device is a domain computer, it's going to basically be flagged as AD managed. So once I hit this save button, what we're going to see here is we now have 3 devices with full access on the network. If I drill down onto that, we can see that Windows 7 device is AD managed and it's now being assigned full access. The actual device itself has been granted full access as well. So he's now a trusted endpoint, and if I had thousands of AD joined computers, all of them would be granted access with that single step. Now, in terms of, if we can just verify again that it was working properly, so I can click on this full access link and it would tell me exactly what condition he passed. So in this case, he had the AD managed flag, so he was being assigned full access. Now, another integration that we can do is antivirus integration. And I'm running Sophos in my environment. So I'll go to the Sophos integration tab and I can turn on the integration, and I'm going to be using on my environment a on-premise solution. So I'll be basically logging into the SQL server of the Sophos AV, and I'll be looking through that database and flagging the devices based on information I see. If the device is running the client, it's going to be flagged AV managed. If real-time scanning is turned off, it'll be flagged AV off. If it's out of date, it'll be flagged AV out of date, etc. So once I hit the save buttons on this integration, we'll start seeing the updates of these devices. Let me go to the main screen, and we can now see there's a device on the network that has limited access to the network. Well, what does that mean? Let me click on it. We can see the Windows 7 PC. It's now in a non-compliant status. There's some additional flags that's been added. It's AV managed, but the AV is off. Why is it getting non-compliant status? Well, it went through the policies top down. AV off had higher priority, so it was being assigned non-compliance. From the end user's point of view, what do they see? We'll go back to that machine. We can now see he has partial access to the network. He can still talk to 100, where my AV server is installed, but he's not allowed full access to the network. I'm denying other things. If he opened up his browser, he'd be redirected to a remediation portal where you can see what the problem is. AV is disabled. Now let's go back and show you how these ACLs work. So when you're getting limited access, we basically decide, when you're non-compliant, you're going to be assigned the limited ACL. And the limited ACLs can be configured here under NAC. And this is basically where you configure it. So when he's getting this limited ACL, he's allowed to send DNS and DHCP traffic. I'm allowing him to talk to 100 because that's the server my AV server is. I want to be able to get AV updates, etc. And he's being redirected to the remediation portal, which we just showed you. And then everything else is being denied. So here, basically stay in this state until his AV was turned on. For the next demonstration, I'd like to show you the automated threat response feature. But before I go into the demo, let me give you a quick overview of how it works. The automated threat response feature allows the appliance to receive alerts or messages from third-party security appliances such as firewalls, APTs, SIEMs, AV servers, etc. So for example, let's say this endpoint is misbehaving on the network. If the firewall detects that it's misbehaving, it can send us an alert message. Could be email, could be syslog. We will read that message and then quarantine the affected endpoint immediately. Now let me demonstrate how the automated threat response feature works. So you probably recall we have a Windows 7 device that's getting limited access to the network because it's currently non-compliant. Now, we have the systems that's configured to listen to different events. So let's take a look at what is currently configured to listen for. One of the events is Sophos infection. And how it's been configured is this is an email alert. So if the appliance receives an email from the Sophos server that has this key phrase in it, spaces would be allowed, we would then check the email for the host name and extract the host name and flag it as infected. A flag just is a marker that we can use to set policy. So that's just how it's been configured. So let's go back to that Windows 7 endpoint. And we see the current status is it has limited access because the AV is disabled and you only can talk to the AV server currently. Let's go ahead and trigger the automated threat response. I'm going to scan this file, which is a malware file. And once the Sophos server detects this as malware, it's going to send an email alert to the appliance, and the appliance will take action. Now this isn't real time because there's a slight delay when using email, but it doesn't take too long, as we can now see that he doesn't have access to 100 anymore. If I refresh this screen here, we're going to see that his access is now restricted because malware or suspicious behavior has been detected. Let's go back and look at the management console again. So I'll refresh the screen, and we can now see that the device is back in restricted state. Down here we can see it's a high-risk device. So if I click on that, we'll be able to see the device. It's been assigned the high-risk role. There's a red flag here, infected. So we can just double check, the high-risk role was assigned because of the infected flag. If we want to know what this flag was triggered by, we can click on it. And we'll see all the devices that have events. In this case here, we see that this time the Sophos infection was reported. And this device will stay in this fully restricted state until the administrator cleared this event. So I'll go ahead and clear it. Now the beauty of this system is that any solution that can send an email or a syslog message can be used to send us alerts that we can take action on and quarantine those devices. Now to help you understand this feature a little bit better, let me show you the actual email that was sent and received by the appliance that triggered this event. So I'll open up the message, and we basically see here's the keyword that the appliance was looking for. And when it saw that, it then checked to see what machine was being referred to. In this case, the host name manage01. It could also be an IP. And that's all that was necessary for the appliance to quarantine this device. So as you can see, it's quite simple to set up, and it can work with any appliance that can send an email alert or syslog alert. Now for the last set of demos, let me show you how the BYOD and guest registration capabilities work. We'll start with BYOD registration. Let me show you how it's been configured. So we'll go to device registration methods. And for device registration methods, there's a default profile. And we're going to allow any AD group to register, although you can't specify what AD groups are allowed to register, what information we want the user to provide when they register the device, how long that registration is going to be good for, how often they must re-log in, and how many devices each user is allowed. So that's how it's been configured. We'll keep the defaults. Now, I'm going to have my iOS device join into this demo environment. So let me go ahead and bring that iOS device on the network. So I just brought the device onto the network. And if I refresh the screen, we can see that an iOS device has now joined the network. I can click on this for more details, and we can see the operating system of the device, the host name, it's an untrusted state, and of course other details. Now from the end user point of view, they would be redirected to a captive portal page where they can input their details. And then with the correct credentials, they'll be granted BYOD access. Now if we go back and look at the main screen, we can see there is now a BYOD device on the network. If we want to see a list of all our devices that have registered for BYOD, we go to Visibility and Device Registration Manager, and this will show us all the devices that have been registered. If there is a larger group of devices registered, we can search for them up here. Now let's show you the guest access demo. We'll use the XP machine, but let me go ahead and create a registration access code for him. So let's just say he's a guest, And I'll basically come to my guest registration manager, and you can have different sponsors being able to do this. Choose the type of guest it is, whether it be a guest that registers themselves, whether a sponsor creates a guest account, or whether it's a consultant. I'll just choose a regular guest for now, and I'll create a sponsorship. So in this case, the default is 12 hours. I can change that if given permission. I'll just go ahead and create an access code, something simple like guest 1 day, and save that. Now I can pass this access code to one or more guests depending upon my settings, and they can use that to register. So let's go back to that XP machine, and I'll close this prompt. So he's still quarantined. If I open up a browser, he's going to get redirected to the Captive Portal page, and as a guest I would click on the Guest Access tab. I'll accept terms of use, and I'll basically indicate that I have an access code. So I'll type in that access code I was given. And then I'm allowed to create my own account for registration. Once registered, I'll be now granted guest access. Now for guest access, it typically means internet only. In my demo, to make it simple to see, I'm allowing him only to go to the default gateway and not the rest of the internal network. I'll go back and show you the management console, and we can see there's now a guest on the network as well. It is the XP machine. He is getting the guest ACL. So what the guest ACL allows is it basically allows him to communicate with 254, and then it denies the rest of internal IP spaces. So with this ACL, he actually can go to the internet if this was an internet connected device. Now let's say I made a mistake and he's not actually a guest but a consultant. I could have given him a consultant access code, but I didn't. So if I want to quickly make him a consultant, I could come here and I can say, you know what, I want to flag him as a consultant. So I'll set the flag consultant. He's no longer a guest. If I go back to the main screen, I now have a consultant on the network. And if I look at his device again, I'll refresh the browser page here, but we can see he no longer has access to 254. He's now getting an ACL that's designed for consultants. So if he was my AV consultant, he would only have access to my AV server. Well, that completes our demonstration of EasyNAC. If you'd like to learn more or would like to request a quotation or an evaluation, please visit www.easynac.com. We'll be happy to help you. Thanks for watching.